We're starting our presentation today of Master Spatial Data Management, Enterprise Level Spatial Information Architectures. My name is Mark Stokes. I'm the Manager of Support and Professional Services here at Safe Software, and our guest today is Dennis Beck. He's the President and CEO of Spatial Business Systems. And Dennis has been working with us at Safe Software. We've been long-going partners and friends, I would say, for quite some time. Dennis, I think, originally started working at IBM and then moved to Small World, where actually, Dennis, I think you got involved with FME in those early days. That would be about 1999, maybe 2000, where some colleagues of yours at Small World, Robert Ledaddy and Brent Henderson, started the first plugin for FME, I think.
That's right. Actually, it was quite a bit earlier than that. It was 95 time frame. So
yeah. So that's amazing. Days. So very early days of Safe Software and the FME product that really kick-started our relationship with working with the Small World databases. And then I think around the time that GE bought Small World, you moved and helped set up Spatial Business Systems. I think that's correct, isn't it?
Yes.
So FME by Safe Software, our role in life, hopefully most of you have seen something about our software, is to connect a wide range of format and data structures together, transform them in a suitable way, and to take the workflows that you've built around that connection, transformation, and automate them. We've got a variety of products that help you do that. We're not going to get into that in a great deal of detail today. We're going to focus on the Master Data Management architectural kind of story that Dennis is going to put together. So with that, I'm actually just going to hand straight over to Dennis and get him to present. But before we do that, we just wanted to learn a little bit about the audience today. So we've got one quick poll to make sure that everybody's awake today, and that is what industry you're in. And I've just lost that poll, so maybe Stephanie can run that for me. Okay, so we're getting in quite some good answers here. And I'm going to close that poll now. And I'm going to share it with the audience just to show that everybody can see where most of the audience is from. So it's a scattering, mostly government, big chunk of utilities, and other. Not quite sure who the others are, so maybe they can chat that into the questions panel. And I will just say before Dennis starts is that on your GoToWebinar panel there is a questions area there, and so any questions that come up as we go through the presentation, fire them off. We'll try and answer them at a couple of stops during the presentation as we go. All right, so with that, we're going to hand over to Dennis and get him to tell us his thoughts about the Master Data Management architecture.
Okay, great. And let me go ahead and show my screen. Okay. So thanks for the introduction, Mark. We'll go ahead and get started here. I'm going to be talking a little bit about, I'll just introduce us real briefly, then we'll talk about master data management, and then we'll talk about the spatial aspects of master data management and how FME plays an important role there. We'll go through some examples, how you get started in it, and just a few comments on the value proposition for a spatially enabled master data management. So a little bit about us. We are a spatial integration firm. We're based in Lakewood, Colorado, and we have a small office in Melbourne, Australia also. So we tend to support those industries that were cited in the poll there, particularly utilities and telecommunications, and do a lot of work in this area, and have been doing this for quite a few years. So, but let's talk about master data management and what it is. Just to get some of the definitions out of the way, some of you may be very familiar with it. Some of you may be completely new to the concept. So, if you were to look at a technical definition of master data management, it would be cited as an architectural approach that supports consistent, common, uniform data management across an enterprise. And that's quite a mouthful, quite frankly. But if you think about that conceptually, that's a very important thing. And particularly over the years of working in information technology, so many of the issues we've dealt with are those multiple data sources and multiple databases that contain virtually the same information, but the information for some reason is different. And when organizations embark on a master data management initiative, it's a big deal to consolidate all their data sources, get them identified as what we like to call a single version of truth or a single reference point for this information. Then when you add the spatial dimension to all of this, the data complexity goes way up. But it's obviously something that many organizations deal with that deal with spatial information, and that is, getting a common database in place that represents truly what the truth is. And an example, just to put this in perspective, of maybe where you have maybe experienced a master data management issue, and that is if you have perhaps you subscribe to cable services at your home, and the cable systems oftentimes have grown by acquisition, and they've developed multiple systems to manage information about you as a customer. And that information may exist in an accounting system, in a CRM, a customer system. It may be in a call center, maybe in a marketing system. And when you as a customer are represented in multiple ways, organizations can have problems when they have new customer offers that go to an existing offer, particularly if that new customer offering is a much better offer than the one that you just bought 30 days or 45 days ago. In some cases, you can have payment issues related to multiple accounts. And ultimately, you can have dissatisfied customers, you can have greater expenses in your various systems and lost opportunities. And that, in essence, is an example of what master data management is. It solves this problem of having these multiple references. And the reference areas are typically called domains. So the customer is a domain, products are a domain, and in the world of spatial, assets are a common domain. And if you were a utility and you were putting in new assets, new infrastructure, and this could be a transportation company, a telecommunications company, you typically go through a process of initiating this new asset, planning and designing it, scheduling it, installing it, and ultimately moving it into your accounting system and then operating it throughout its life cycle. And throughout that process from initiation to operating and ultimately decommissioning an asset, you will be touching many, many different systems that rely on the spatial information. So it can be a CAD system, and obviously you'll install it in a GIS. The work management system will be involved with planning and estimating. The accounting system will be dealing with the depreciation aspects of it. And then there are various operational systems, inspection systems, other engineering-related systems that could all be touching this information and managing it in one way or the other. And so this is an example of the issues we get into in the world of managing spatial information, of all the different systems that touch it. Yet then we have that opportunity where the information deviates and starts to vary, and there's an inconsistency and a lack of understanding of what really the version of truth needs to be. And it isn't just utilities. We could go on and on with different examples. Transportation is another area where systems can be used to manage the assets, the signage, the appurtenances, right-of-ways that exist. Utility information is quite extensive in your environment, so there oftentimes are separate systems just for managing the utilities around a railway network, for example. And environmental data, vegetation management data, all those things rely on spatial sources, but they can oftentimes be separate applications. So therein lies the spatial master data management challenge. Then, of course, the next question is, what has caused these? Well, in the days of the 90s, when we were actively working, implementing lots of new first-time GIS environments, the GIS became the center of the universe, and it started to develop many, many different interfaces to these peripheral systems. And the data models were based on the legacy systems that were there, and as these systems got more and more interfaces and related applications, they became very expensive to upgrade. And thus organizations started to realize, hey, we have to do something different about how we manage our spatial information. There are still a lot of issues in these systems then as the data gets enriched in various systems where the data gets duplicated and it starts to take on a life of its own, which causes data integrity issues. Then ultimately the systems just lose flexibility because you cannot change one system without having to change another system, which may have dependency issues and various problems that you get into when you have this large mass of different databases. Then ultimately organizations can't move forward with the flexibility they need. They start losing functionality and they're not positioned for the really exciting things that we're seeing happening in the geospatial industry around advanced applications and analytics and all the sensor-based data that's coming in from the Internet of Things. And I realize the Internet of Things can be quite hyped, but it's really quite a reality in terms of all the information that is coming in. So before we get into that, Mark, I was going to take a pause to see if anyone had any questions.
There was one question, as somebody brought up here, and that was, does FME and spatially enabled master data management replace any of the other core master data management products that are out there in the marketplace already?
Oh, that's a good question. You know, I'd answer not really. You know, MDM today is focused on various domains, and the common ones, as I mentioned, are customers and products and such. Spatial information can cross any domain, and we most commonly see it in the context of assets. So those MDM products that need to process spatial information take advantage of something like FME, do the kinds of things we're going to be talking about to pre-process, validate the information, and FME server can play a key role in that to really augment those applications that really aren't designed to handle spatial information. So FME can do a lot of things. There are specialty products out there from a variety of players, and so FME becomes an enabler for those. Or you can do quite a bit of FME just focused on your specific domain. So yeah, thanks for that. And feel free to keep the questions coming.
Yep.
Okay, so next slide here is just looking at the conceptual architecture of a spatially enabled master data management system. And this isn't necessarily that different from any MDM architecture. But in the case of spatial, you're going to be coming in from different data sources of GIS, CAD, others. It could be mobile applications or other sources of spatial information. And ultimately, those then get transformed and they reside in a master repository, which is referred to as an operational data store. And we'll be getting into the architecture of the operational data store in just a bit. And that then, prior to getting into the operational data store, or the ODS, we'll refer to it as, it needs to go through a validation and transformation, transformation and validation process. And ultimately, some aspects of data integration. Now, we're going to focus on all three of these and how it has been done in various spatial MDM projects over the next several slides. And once this is in place, then this becomes the enterprise database that supports things like asset management, planning activities, the reporting and analytics, all those different applications that need a much richer base of data than would be provided by maybe a core GIS system in a working operational environment. So what are the elements of a spatial MDM? Well, we're at an FME webinar, so SAFE's FME product is obviously a real core of this. It's a powerful technology that supports a lot of the data transformation activities, a lot of the data validation, But FME is also has a very extensible architecture. So there are FME-based frameworks that ourselves and others have built to support the whole MDM process. And then working with that is the operational data store, which we'll talk about in a little more detail. And that's really the software components. But when you look at master data management, you have to consider it as more than just a product that one would buy off the shelf. It really involves technical services, consulting, building it around your business strategy, and then analyzing the data and the modeling aspects of the data, along with the implementation expertise required to do that. So we'll now get into more details of these components. FME, again, what it does so very well is the data transformation, and at the heart of an MDM is support for a canonical model. And the canonical model can be considered like a least common denominator. It's that model that supports all the characteristics of the information that are managed within the operational data store. And when you have different GIS environments and you're dealing with putting them into a common environment, you're going to deal with all the things that FME does really well. Merging features, splitting features, modifying the attributes, getting them into a common environment. There are capabilities available to support deduplication, which in our industry we call conflation, and in the MDM broader industry they refer to it as deduplication. Managing the relationships, and then things that we'll talk about in more detail in just a bit are the topological aspects of spatial information, like getting a common network model in place. Of course, when you deal then with the different systems, you have to deal with things like data management, difference management between the different spatial systems, and the interoperability aspects, and if you haven't used FME, there's actually a lot of inherent capability to do that. And I don't want to preempt your future releases, but we know that SAFE is going to be doing additional things to deal with difference management, so differences can be managed between different systems. And of course, SAFE supports just about every possible format out there. And then there's a lot of validation work that can be done right within the FME environment. So FME is obviously a real key component of this architecture. From a synchronization standpoint, synchronization is really interesting with spatial information. If you look at different systems, be it an Esri or a Small World or an Intergraph system or a CAD-based system, the systems may look the same when you view them, but something like a spline can be modeled as a Bezier curve in one system, or a non-uniform rational B-spline in another, or polylines in another. And when you're moving data between one system and another, those differences may not be quite as critical, but when you're going back and forth, you have to really retain the geometric fidelity between those systems. And the two-way transformations are obviously very important too, so the configurations between the different models can be retained. And of course, the topology. So different systems have different models versus the other systems. So there's the to-from versus the node-link network models, and that really becomes the foundation for what needs to be a network model of truth. One example of transformation is internals, and internals are an important example of the complexity that needs to be addressed when you're developing a repository of master managed spatial information. An internal was a concept that was made popular by Small World Systems, which is now GE, back in the early 90s. And it's commonly used to show detailed information about substations, complex process diagrams, or other intricate data that often crosses the realms of GIS to CAD. And in these cases, master data would reside in the operational data store, the ODS, but the information could be moved to the GIS for cartographic visualization, or it may be edited in a CAD system and used in a distribution management system that is tracking the status of a network with near real-time sensor-based data to support the overall system operations. So this is an example of the kind of transformation you can actually do with FME. Obviously challenges that need to be done to make sure it aligns with the business process and retains the richness of the information between the different systems. getting into that network model aspect, organizations that use networks like pipelines, utilities, telecoms, transportation agencies, they all have multiple consumers of network information within their business. And so, the models, we mentioned the link nodes and the to-from models, but there are also linear referencing models that are particularly important in pipelines and DOTs. So establishing a canonical network model or a network model of truth really is one of the key things that needs to be done to support all the consumers. And this is a particularly interesting challenge, even when within common systems. There can be different network model representations. So there are some, and then there need to be transitions between the systems too. So this is, again, something that if you haven't experienced this with SAFE, you can actually extract all these information from the systems and develop common representations there. And this also opens up some interesting opportunities for the network tracing to be used as a service in various consuming applications. Data validation is another example of, or another case that needs to be done in terms of the overall framework that we showed earlier. And that involves just the overall checking of the validation for the data, and there are numerous categories that need to be considered. Intra-facility is within the particular feature or asset, and determining are the attributes in the prescribed range, what are the relationships, the connectivity aspects, and then the relationships between the various assets too. So there are a number of different things. These are just a few examples. They obviously become unique to the specific characteristics of the data, but these can be established again within the MDM framework to ensure that the valid data is being managed within the operational data store. So the data integration aspects, so we've discussed transformation, we've discussed validation, now we'll have a few slides on data integration. There are a number of considerations here, and we refer to this area as job management. Probably could be a better name we could come up with, but different spatial systems have various controls over the data. And typically in a CAD system, for example, it's about drawing, it's about laying down the lines, and in a GIS system, oftentimes it can be much more structured and about building models and relationships. And organizationally, different parts of the organization may have different cultures in terms of how they manage their visual graphic spatial information. So when organizations move data from a CAD system, for example, to a GIS system, and they're doing this in a persistent manner, there needs to be a mechanism to manage that data stewardship going between the systems, because you just can't enforce necessarily all those behaviors between the different creators and consumers of the data. And the job manager is a mechanism that we've put in place to provide controlled data stewardship. And you can think of it as getting a user-assisted data integration so that when the data is being presented to a user, for example, if it's coming into the ODS or a master GIS repository, the data stewards can play back this external information coming into the system. The validation framework gets activated, and then that steward can then ensure that the valid data is entered into the system without having to completely re-enter it, which we find is just a tremendous problem that organizations still have here in 2015 of re-entering data between systems. And so this really does a smart assist, so to speak, that allows you to take these disparate sources of information and put them into a common environment to do the proper white space management and such. This is not to say that there aren't many sources of data that can't be directly read into an operational data store, but there are certain sources of data that really need to be read in a more controlled manner, and that's the nature of job management as part of the integration framework. Global IDs are another really interesting concept that need to be implemented when you have multiple persistent GIS and CAD and other systems that consume spatial information. So typically these systems will all have their own system IDs, And so there will be a unique ID for that data that may exist in Esri, another one for the data that's in AutoCAD, and another one for the data that may be existing in another system. And the concept of a global ID is a higher level ID that serves as a lookup so that you can link all these source features and have a unique identifier associated with them. So FME actually is very, very supportive in using this during the whole data synchronization process. It can confirm and deal with the lookup process, validate whether or not there is a global ID, and support this whole capability. So that's another aspect of data integration that needs to be considered when taking on a spatially enabled MDM project. Here's just a little bit about the Spatial MDM architecture. We've talked about the operational data store, and we've talked about the different systems and such. So if you look at these here, you can see over on your left are these source systems that can be providing data into the operational data store. And then within here is the canonical data store, which is that common model that supports the entire environment. The data ultimately gets staged and goes through a validation process. You can see the job manager down at the bottom, which really supports the controlled entry of data into the system. And that's really the operational data store over on the left-hand side. Now, organizations and a number of people have always asked the question, well, is this the same as a spatial data warehouse? And my concept, my answer to that is no, not really. I mean, you can use this for warehousing type applications, but the operational data store is really a transactional database that's supporting the management of all this information. Spatially enabled data warehouses would be a mirror of the operational data store that would be supporting more of those OLAP, online analytical processing kinds of applications. Again, this doesn't mean you cannot use operational data store depending on the nature of the consumption and how intense the queries are and such. But if you're looking at these different databases, you can really consider the application platform, the analytic platforms to be really much more of a viewing consumer to support things like analytics and maybe studying the reliability of assets, maybe looking at temporal views of the system and augmenting that data that way. So so that's a little bit of the way the broader spatial MDM architecture looks. If you go into the operational data store, you can see it's comprised of a number of different things. The data initially gets staged into various staging tables, and these, depending on the nature of the database, can be version managed or non-version managed. And then it gets processed by ETL, FME server, and that's where the quality assurance, quality control, the whole validation framework takes place. And as you can imagine, in addition to the canonical data store, which is handling all the features, and this is a utility example. I apologize if you're outside of the utility industry, but consider those perhaps your assets or other spatial sources. Those get enriched by the metadata models, the need to potentially have different symbology models between the systems also needs to be managed. So the symbology would have its own repository, establishing the common network model, which we discussed, as well as administration and access models, and then other things related to for example, design, and consider that to be the changes that are happening to the assets within the system. So that's peeling back a layer, looking a little bit more of what the operational data store would look like in these installations. So I want to cite a few examples. We worked with a number of utility organizations, and their needs tend to be quite similar, but these are large organizations that may be using Small World for keeping their network model of the system. Bentley, which is their MicroStation CAD product, which is often used for design. Autodesk and Bentley seem to coexist in different parts of organizations, so it may be used. One may be used for distribution design, another may be used for detailed design of substations, for example. And Esri is very popular in utility organizations, and these systems tend to coexist. Esri has some nice applications more around visualization, vegetation management, and such. So these, the organizations we run into may have their base information in one system, they move it to another system, but then they start to enrich it. IBM and their Maximo product has quite a bit of spatial capabilities supporting operational aspects of asset management. So that was the situation with this particular organization, and they were having also quite a few challenges related to the fact that they had an acquisition and they needed to integrate the data from another system, deal with system upgrades, which were becoming very, very expensive because they had so many different interfaces, and they had duplicate data entry issues. So this particular organization dealt first with defining the process integration issues and establishing the future state architecture. And then they extended their spatial data store to move it to a purely relational environment that really wasn't a GIS data store per se, but was the operational data store. And that was populated using FME server, and then a synchronization framework was put in place. In this particular case, for a utility of this size, it was an Oracle-based database, and then it used the SBS software framework to support the validation and the integration aspects of it. And this particular utility, they're in the process of implementing the job manager for their controlled updates. And then they are also doing the data consolidation from their acquisition. And so that's an example of how this is being used in a utility environment. And what there's some of the benefits they're already starting to realize is that now this is becoming the platform that's providing information for mobile. And if you are, can really appreciate mobile as one of the areas of just great growth and change, and any organization that relies on mobile workers, which utilities, municipal governments, telecommunication are all just heavily dependent on that. And of course web too, in terms of just disseminating the information across a broader set of users. They're also implementing vegetation management. And then a big part of this is just streamlining the whole asset management process around their asset management system, which in this case is IBM Maximo. So that's an example of how a utility is using spatial MDM. This is happening more in Europe. Our next example is around smart cities, and MDM is starting to be implemented in those organizations, particularly by some of our FME partners over there. And this is something that really impacts governments all over the world. They are dealing with a large number of existing spatial data sources, and they have all the same issues that any other organization has when you have to integrate this, duplicate it, and validate it. But the sources are continuing to proliferate. There are more and more of them coming in. And so the key activities they've been involved with are getting the third-party data sources, performing analysis for policymaking, and then really getting it in so they can integrate it to the rest of the business and support the same kinds of applications, mobile, web, and then anything related to streamlining the city management business processes. So the smart city initiatives are really a very powerful potential consumer of this. The next area is kind of a favorite topic of mine, and that's around asset analytics. And when you are looking at organizations that have large amounts of assets, and we're talking off, it doesn't have to be this big, but any utility or telecommunications organization of an investor-owned utility could be looking at assets in the billions of dollars. Those are a portfolio. They're really a financial portfolio and need to be managed as such. So when decisions are made about maintenance, about replacement strategies, all those kinds of things, there really needs to be a very rich set of information in place so you can start analyzing, simulating, and looking at that information both to determine long-term strategies and operational plans. So in addition to the GIS data, the asset data, there's going to be a rich need for financial and accounting data. We know and see more and more sensor data coming, but there are also other sources too, such as a lot of aging workforce information and knowledge-based information. And this has to be then melded with the key performance indicators that are driving the organization. So with asset analytics, I'll just cite a few examples of studies we've done with our clients. In this particular one, with all the bright colors in the upper left, this is an asset analytics study that was done on transformer reliability. So transformers are very costly assets. I'm talking power transformers for electric utilities, and the replacement strategy is really quite challenging on what to do with those when they fail. And these are assets that can last, anywhere from 30 to 80 years in the field. They cost millions of dollars a piece, and getting all the information and the history together has some pretty significant implications in terms of financial performance of the organization. So you can see here in this particular case that this curve in the middle is showing the different replacement strategies, and this was all done by consolidating all these different information sources, then putting a new model together, which we can show in the bottom left here, of defining the degeneration curves of these assets and then running simulations against this master set of spatial information. The upper right here shows an example of differential sensitivity. So this is a curve for every dollar invested, how much do you get out of reliability? And so again, this is another example of analytics you can do when you're able to get all this master data together with the related information sources. And then the other one that I wanted to share here is a aging inventory problem, and this was a different domain that we were dealing with in the bottom right. And what was kind of interesting, if you look at the one curve on the master data management's failure projection, that is the red line there that was when we interviewed the subject matter experts. It showed they were really anticipating that these assets, because they were so old, were going to fail very quickly. But when they analyzed it against all the available data, the asset failure curves were really the other two that were there. So the implications and savings for this particular study was over $25 million that was identified just by being able to assemble all the information, analyze it, and put it into a coherent analytic model. So there's a lot of opportunity around not just data consolidation and improving integration and such, but it really becomes a platform for supporting analytics and the kinds of things that people are talking about with big data. My comment is the big data doesn't have to be too big. It just has to be assembled in the right fashion to start making much better business decisions than organizations are already. So getting started with Spatial MDM, let's talk about this a little bit as we close up today. One of the first things that needs to be done to get a successful initiative moving forward is to establish a vision. And MDM is all about the data, but really to be successful, you have to be about the business. And if you're a government, as far as I'm concerned, it's a business too. It's a business of taking care of the assets that are entrusted to by the government and keeping people safe and secure and all the other things that you're doing. But it can be managing growth. It can be streamlining processes and cutting costs. It could be optimizing investment decisions. There are just a number of things that have to be aligned with as you develop your MDM strategy. And then ultimately you want to turn that vision into a roadmap at a strategic level. This is one of those businesses where it's very easy to get into details of systems and network models and data models and such, but keep your vision strategic and keep it measurable so you can show benefits and how it's going to be aligning with the major shifts in technology that will be happening, which we know are things around mobile and Internet of Things and big data and all the other things that we are dealing with in our world of spatial information technology. And then from a getting started standpoint, oftentimes the best thing to do is to solve a very visible, practical problem. And you may have some ideas that have already come to mind as you've been listening to this presentation. If organizations try to do everything at once, they will really have risk of failure in their systems, to be quite honest and frank about it. Don't overinflate what it can do, solve an initial problem, and then move forward with it from there. And since MDM isn't a product, it really requires full involvement of people and processes, technology, bringing in the right expertise, and then dealing with the change management, and in particular the data governance aspects of MDM. So it really requires a much more efficient linkage of different parts of the business. And this isn't done typically at a departmental level. It has to be done at an executive sponsor level. So to get, next comment is, once you have your roadmap in place, that drives down your architecture. And with these kinds of systems, the architecture will evolve. But the architecture still has to be defined in place and built in such a manner that you can support the evolution that's inevitably going to happen. And since it's done at a senior level, those senior stakeholders not only need to be involved at the initial part of the initiative, but they need to be involved along the way so they can see the value. And they need to be enthused about the kinds of things they will get in terms of being able to have better business insights, making better decisions and such. And so consequently, it needs to be budgeted for accordingly. And it's best budgeted when it can be associated with other core business initiatives that are getting funded. And then knowing that it's going to change, and things always do change, that architecture needs to be flexible. And this is really an area where FME can help quite a bit too. It's just a very powerful and flexible tool to do this. It is really critical for anything related to spatial MDM. It's got such rich support for spatial information. There's really nothing like it out there. It's got a very rich library of tools and transformers that form the foundation for a lot of what we've been doing in MDM. And then it can be customizable too, and customizable in a visual manner through all the workbench capabilities and such. And if you do look at the commercial solutions that are out there, when people talk about MDM, obviously you can, for a large organization, you can invest quite heavily to achieve an MDM solution. SAFE is really very cost-effective relative to a lot of those solutions that are out there. So it really brings a lot, and it brings a lot of value to the table from an MDM standpoint. So I will close by talking about the value proposition for spatial MDM. Just these key areas here. For organizations that are doing a lot of duplicate data entry, MDM can really streamline workflows, and by having the data, the spatial information in a master data managed environment, those re-entry and all the different things related to the stovepipes of information can be broken down to support improved business processes. And this, of course, drives improved productivity from that standpoint, but also the improved productivity that can support mobile operations, for example. And once the architecture is in place, the deployment can be much faster. Particularly, one of the areas where we get a lot of feedback is around GIS upgrades. And when GIS environments are heavily customized, they lose their ability to be flexible. And this really offloads the GIS of some of the data management responsibilities that aren't core to GIS a lot of times. And so this flexibility can really support faster deployments and more flexibility, a greater ability to take advantage of the latest strong features that come out from the GIS vendors. And consequently, the ability to reduce custom applications is also quite powerful too, because it puts you in a position where you can choose best of breed, which most organizations like to do anyway, versus developing custom functions within AGIS. And then ultimately, as I've been sharing throughout the presentation, this does become a platform for doing the more advanced things that every organization tends to want to do around analytics and taking advantage of a lot of the new technology shifts that are starting to happen. So, and ultimately, there's real payback too. And we shared the one example of the transformer analysis study. As this data becomes more and more prevalent, this analysis doesn't have to be a big data gathering effort. It becomes an analytical effort based on the data sources that are available. So, in any event, that is the essence of my comments. If you have questions, please, by all means, we have some time here. We've got a little bit of time before the hour is up, so you're welcome to ask questions. You are also welcome to get in touch with us. We support these initiatives around strategic planning and the consulting, training, implementation, and support, not just around the MDM aspects, but also with FME. So with that, would welcome any questions you may have for us on the topics today. So.
Yeah, I've got a few questions that have popped in. The audience did line them up a little bit, Dennis.
Okay.
But yeah, just firstly on questions about the integration services. So just to clarify for some people, at SAFE we don't really offer any consulting services through SAFE, and so Spatial Business Systems and Dennis's team are an integrator. We have an FME certification program, and so Spatial Biz has FME certified professionals, and then they build those integrations of the FME. So somebody was asking about what the main products that you've put together along with FME, and I think that's probably just the best of breed depending on the environment that you're working in. Is that correct, Dennis?
That is, yes, and there are a lot of dependencies on which products you're involved with. We tend to work with all the major platforms that are out there, and so those are questions. Would be happy to you're welcome to send us an email. We could get into a more detailed discussion, unless you have some real specific questions anyone wanted to ask today. So.
Yeah, hopefully we've got your contact details on one of these slides. But we can post those out in the follow-up email that everybody will get from this webinar. Somebody's just thrown in a great question from the UK Ordnance Survey, and I was going to mention that earlier on. Actually, on one of your earlier slides, you had shown the pattern of integration of spatial data sources with other sources like asset management and so on. And on the spatial data sources, you had GIS, CAD, and other. And so under that other, of course, is BIM, because really all these spatial tools, the GIS, CAD, and building information modeling tools, are converging in many ways. And so they all fit into this kind of pattern of master data management. And particularly the BIM, because on the architectural and the construction, civil engineering construction side, there's so much detail in those building information models, right down to the door handles and what kind of toilets you've got in a building, and that all has to be integrated cleanly.
Yeah, that's a really good point, because when I showed the internals presentation, that was much more of a utility asset example, but BIM, think of that as quite analogous to the internals. It's a confined area that has greatly enlarged detail, and that all needs to be managed too. So that's a very good point. Yeah.
And then a great question about, well, more of a comment really about legacy systems, and this is a very good role for FME inside and outside of master data management. But he caught me by surprise because it's kind of early here. He said, what about GIGO, which is garbage in, garbage out? And so really the question was around how to validate old legacy systems as they're coming into a more modern GIS or CAD or spatial environment, so that it's sanitized before you load it into your new spatial environment. And that's a very good role for FME, and obviously can be integrated into this MDM platform as well.
Yeah, it really is. That validation framework plays a real key role in that. And I think the other thing that I will just say, I've been involved doing GIS migrations for 25 plus years now, and they've always been, move over, pull the plug, And with an MDM architecture, you can really evolve your system more, which is really an important thing. As these systems get more complex and more integrated, they are not easy to just uproot and move to another system. So MDM and FME, all of FME's capabilities of managing difference and still retaining fidelity in the source systems can be really valuable in terms of determining, building a longer-term strategy that allows you to more painlessly move from one environment to another over time.
Yeah, and now people are starting to, that's good, and now people are starting to fire in some questions. And I forgot to mention in our introduction that on the world tour in April, Dennis gave a sort of more condensed version of this presentation at a couple of our world tour events in Denver and the one I was hosting in Houston. And we had in the Houston event, we had a strong discussion about global identifiers and extracting differences, which you need to do if you're going to extract and synchronize databases. And somebody's asked that same question on, what do you do if you've got an unintelligent kind of database, or particularly CAD system, where the GUIDs are not really persistent, and so it's hard to get those differences out. And that all can be done, but obviously if the databases don't manage the change history very well, then you're going to have trouble extracting those differences for your synchronization.
Yeah.
But Dennis, I think you guys have written some tools for both Oracle and GeoDatabase for extracting differences, and your Small World plugin also extract differences from all of those databases.
Yeah, and we've done some other things that have dealt with some pretty unstructured data, and obviously that's not what you want to have to do, but sometimes you get in positions where you have to do that kind of thing. So this is also where that whole concept of the job manager can be valuable too, where you're getting this unstructured data coming in. You really realize that it is not, you don't have enough confidence in it that you can promote it into your master data repository. So you have an intervention scheme in place so that you can make sure it's valid, can potentially be corrected, and then be moved into the database in a trusted manner.
Yeah. And somebody has also pointed out you didn't really talk about the return on investment side of this, that an organization can realize if they really buy into this prospect of master data management.
It depends on the organizations and the problems they're solving. I gave some examples of asset analytics, which they're extremely high returns. The things that a lot of organizations do look at, though, is just productivity of individuals and duplicate data entry. Broken processes in terms of getting current data to support a business can be very costly to organizations from a safety and reliability standpoint when you're managing assets and networks. So they're, depending on who you are and your business role, they're all different kind of push buttons you can deal with around that. And that's part of, defining your initiative, is really understanding the specifics of the problems you're trying to solve.
And then another good question, and I got to say that if you have asked a question and we don't get to it, we will be following up afterwards because there are some great ideas flowing here. So the other one is a question about, well, if I've got multiple transactional data stores and I move that data into a single version of truth database, how do I get the corrected data back to those original users? But I don't think that really is the concept of MDM, is it? And correct me if I'm wrong. I think the idea of master data management is that the owners of that data whether it's the small world database or the asset management database, are responsible for that data, and you're just moving it through the data store to distribute to other people.
That's correct. That's part of the, there's a lot of process improvement that happens around this. Cleansing of databases, improving the validation, but also processes. If you're creating data that isn't effective for managing the business, then you may need to change what you're doing and how you're doing it. And so there are obviously change management aspects to that, and sometimes that can be done easily, and sometimes you can't. And there are different approaches you'll take depending on the nature of the data source, because a lot of organizations may not be able to control that data source if it's coming from someone external to the organization.
Yeah. Yep. Yeah, so I think master data management is about identifying who owns which pieces of the data and then how to distribute that data out to other people on the sort of data network, as it were.
Yeah, there's a whole aspect of data governance that we really haven't talked about that kind of goes hand in hand with master data management too. And again, it really depends to the extent of which an organization wants to take this on. There can be some pretty fundamental issues you can solve, and then there are some more serious master issues that can be addressed too. So.
And I'm not quite sure whether this comment from somebody tongue-in-cheek, he says, publishing the data out there as is can highlight the quality issues and therefore get owners to do something about it.
Yes, that's called airing dirty laundry, right?
Yeah, right. Yeah, and then just last, I think we're going to wrap up with the Q&A, but thanks a lot for participating, those of you that have asked some really great questions here. And so finally, I'm going to wrap up with somebody asked, well, how much of today's content is salient for an MDM environment that is non-spatial? And I would say most of it, really, actually, although our focus here at FME is on spatial data to a large extent, we do have a lot of users who use FME for non-spatial data, and I think Dennis has probably worked with that as well.
We have. It's got an amazing set of capabilities for moving any kind of information around. So yeah, it's a lot of good questions today, and I'd like to thank everybody for listening. We had quite a good audience today, and please don't hesitate to reach out if you have any further questions for us or for the SAFE team. You can see my contact or the info at Spatial Business. Either one of those will work if you want to reach out to us.
Yeah, and so just a quick wrap up that we'll have. So I'm going to take the presentation back again. So, Stephanie's jumped the gun, so that's good. And so, yeah, thanks very much, Dennis. That's great for participating in our webinar here. We've been long partners with SBS, and we will continue to work with them. They're one of our key integrators, and as I said before, have a raft of FME certified professionals on staff. And we will be sending out an email as a follow-up to this webinar, and we'll include Dennis's contact details there if you didn't catch them early on. So if you want to talk to him about the ideas and implementing them in your own organization, you can do that. Just to mention, for those of you that have not used FME that much or have used FME a lot but possibly need updating, remember that we regularly offer free online instructor-led training as a sort of an introductory desktop kind of training. And I will mention that Dennis's team also offers on-site training if you want more customized training for your work environment as well. And so with that, I think we'll close for today. Thanks everybody for participating. Those were really great raft of questions for those from those of you that did give us input and feedback there. Some great feedback and questions. So thanks very much. Thanks to Dennis, and of course always thanks to our back-end team, Stephanie and Robin, who host these and organize these webinars for us. Thanks, Dennis.
Thank you. All right. Bye, everyone.
Bye, everyone.